Before starting, put the auto-generated YouTube subtitles in French or your mother tongue to get everything, and slow down or speed up the pace as needed. If you don't have time to watch it, just listen this video as a podcast while doing something else. Now listen and learn English as exploring our world. What if time, the steady march from one moment to the next, is just an illusion? Every clock, from a grandfather clock to your smartphone, might only track our perception, not reality. Our experience of time is deeply subjective. An hour can feel endless, or a week can vanish in a blink. Prepare to question everything. The flow of time may be the universe's grandest illusion. Our journey through spacetime begins with a simple question: what is time? For centuries, Newton saw it as a universal clock, ticking steadily for all. But Einstein shattered this view, revealing time as flexible, woven with space itself. In the chapters ahead, we'll explore how our minds and the cosmos shape our experience of time, and why its mysteries still captivate us. For centuries, people believed time was like a single universal river, flowing at the same speed everywhere. For everyone, Newton called this absolute time, the master clock of the universe, steady and unchanging. But in our lives, time feels different, sometimes dragging, sometimes flying by. The clock's time and our mind's time don't always agree. Soon, science would challenge everything we thought we knew about the universal clock. Our minds keep time in mysterious ways. When we're absorbed in something we love, hours can vanish in minutes. But in boredom or fear, every second drags. Our brains stitch together moments, creating a personal timeline, one that's elastic, shaped by emotion and attention. So, while clocks measure steady time, our inner world tells a different story. Time as we truly feel it. Time splits into two. Physical time, objective, measured by atomic clocks, the backbone of physics, and psychological time, subjective, shaped by our minds and emotions. Physical time is the universe's unyielding framework, but psychological time is how we actually experience life. For centuries, science kept these worlds apart, until Einstein shattered the divide. He showed time isn't absolute. It bends, stretches, and warps, blurring the line between physics and perception. The journey into the true nature of time had only just begun. In 1905, Einstein's special relativity upended Newton's universe. He declared the speed of light constant for all, forcing time itself to become flexible. Space and time merged into spacetime, where motion slows your passage through time. This is time dilation. The faster you move, the slower your clock ticks. At everyday speeds, it's imperceptible, but near light speed, time nearly stands still. There's no universal now. Each observer has their own. Time became personal, and the universe's clock was forever dethroned. The twin paradox. Alice rockets to a distant star at near light speed while Bob stays on Earth. Alice returns, aged 10 years, Bob decades older. Why? Alice's high-speed journey slowed her time. She's traveled into Earth's future. The asymmetry comes from Alice's acceleration. She's the true traveler. This isn't just theory. Atomic clocks on jets confirm it. Time's flow depends on your path through the universe. Einstein's general relativity revealed gravity as warped spacetime, not a force. Massive objects bend spacetime, and clocks tick slower in stronger gravity, gravitational time dilation. At sea level, time runs slower than atop a mountain. Near a black hole, it nearly stops. Even your head ages faster than your feet. These effects are tiny on Earth but crucial for technology. GPS satellites must correct for both speed and gravity's impact on time. Without Einstein's insights, your navigation would be lost. Relativity isn't just theory, it's in your pocket. GPS satellites orbit fast and far from Earth, so their clocks run differently due to both special and general relativity. Engineers correct for these effects. Otherwise, your location would be off by kilometers daily. Einstein's century-old ideas keep your map apps accurate. Every time you navigate, you're using warped time. The ghost in your machine? It's Einstein, guiding you home. Cosmic rays from space constantly hit our atmosphere, creating showers of short-lived muons, particles that shouldn't survive the trip to the ground. But thanks to Einstein's special relativity, their clocks slow down as they race near light speed, letting them reach us. These cosmic messengers are living proof that time itself stretches and bends right here on Earth. Relativity's effects on GPS and muons are subtle, but near a black hole, time bends to its breaking point. At the event horizon, gravity is so strong that time slows to a halt for anything falling in, frozen forever from an outside view. But for the astronaut inside, time feels normal, even as the universe outside speeds up and races by. Einstein showed us time is flexible, but there's a deeper mystery. Why does time only move forward? Physicists call this the arrow of time. Yet the laws of physics work the same both ways, forward and backward. The answer lies in thermodynamics and a concept called entropy. Entropy is a measure of disorder in a system. Think of your bedroom. There's only one way for it to be perfectly tidy, but countless ways for it to be messy. The second law of thermodynamics says disorder, or entropy, always increases over time. That's why time moves forward, rooms get messier, eggs break, and the universe becomes more chaotic. Time's arrow is really just the universe's story of becoming progressively messier. So this whole idea of entropy giving us time's arrow leads to a really big question. If the universe is always getting more disordered, then it must have started out in a state of, incredible order. And yeah, actually, our best cosmological models say that's exactly what happened. The universe kicked off about 13.8 billion years ago with the Big Bang, which was a state of super low entropy. It was insanely hot, dense, and totally uniform, a super specific and ordered starting point. Imagine the entire universe at that moment as a perfectly wound-up clock, or like an egg that hasn't even cracked yet. Ever since then, the clock has been unwinding, the egg has been shattering, and the universe has been expanding, cooling off, and turning into a bigger mess. The arrow of time you feel every single day? That's a direct result of this cosmic beginning. Every time something happens that can't be reversed, like an ice cube melting in your drink or milk swirling into your coffee, that's a tiny echo of the universe's huge journey from its low entropy start to its high entropy future. When you pour milk into your black coffee, the two liquids start out all separate and ordered, but as they mix, the molecules spread out into this chaotic light brown mess. That's way higher entropy. And seriously, you'll never see the milk and coffee just unmix themselves, getting all neat again, because that would totally break the second law of thermodynamics. This thermodynamic arrow of time runs everything in our lives. Even aging is just entropy increasing inside our bodies as our cells and systems get more disordered and less efficient. Making a memory? That's your brain doing work, using energy and bumping up the universe's total entropy. Even just breathing follows the rule. We breathe in ordered oxygen and breathe out messy carbon dioxide and water vapor. Basically, we're all open systems, keeping ourselves organized by making the world around us a little more disordered, surfing on this huge cosmic wave of rising entropy. So while the basic laws of physics might not care which way time goes, the state of our universe definitely does. It's got a clear story told in the language of entropy. The past is different from the future because the past had lower entropy. This gives us a pretty powerful, though statistical, explanation for why time only goes forward. It's not fake or anything. It's a real thing that comes from how our universe started out. The ticking of the clock is just us sliding from the perfect order of the Big Bang into a universe that's getting more chaotic and honestly more interesting every day. So, building on Einstein's idea of space-time, some physicists have taken things to the next level and come up with one of the wildest ideas in all of science, the block universe. This model says that the difference between past, present, and future isn't actually part of reality. It's just a stubborn illusion that our brains create. In this view, which is sometimes called eternalism, all of time, every moment that's ever happened or ever will happen, already exists. The whole history and future of the universe are laid out in one huge, unchanging, four-dimensional block of space-time. It's all there, all at once. Think of space-time like a giant loaf of bread. Each slice is a different moment in time, a snapshot of the whole universe right then. One slice is when dinosaurs walked the earth. Another is the moment you were born. A slice further down is right now, as you're hearing this. And even more slices represent tomorrow's breakfast, next year's holidays, and even the very end of everything. According to this idea, time doesn't actually flow from one slice to the next. Instead, our consciousness just travels through these slices one after another, like a flashlight beam moving along the loaf. This eternalist way of thinking changes a lot about how we see existence. It means the past isn't gone and the future isn't just a bunch of maybes. Stuff like the signing of the Declaration of Independence or building the pyramids isn't just history. It's actually a real part of the space-time block, just as real as the city you live in. And the future? It's not a land of endless possibilities, but a fixed landscape that already exists. Your life, start to finish, is a complete, unbroken world line winding through this four-dimensional loaf. The feeling that time passes is just our limited perspective, stuck in the moving spotlight of the present. This matches up perfectly with Einstein's relativity, which, like we've seen, gets rid of the idea of a universal now. If two people moving at different speeds can't agree on what's happening at the same time, then there's no single special present moment. The block universe solves this by saying all moments are equally real. The past, present, and future are just directions in the block, kind of like up, down, left, and right in space. Even though it feels pretty weird and kind of unsettling, this model is a really strong and elegant way to take relativity seriously. It gives us a picture of the universe that's static, complete, and, well, timeless. The block universe model says the future is already set. Every choice, every moment, already exists in space-time. This changes how we see time travel paradoxes like the grandfather paradox. In this view, you can't change the past. Your actions were always part of history. It's a powerful idea that challenges our sense of free will and what time really is. The quantum double-slit experiment is one of the strangest mysteries in physics. Fire photons at two slits, and they act like waves, creating an interference pattern. But if you watch which slit they go through, the pattern vanishes. They act like particles. It's as if observing them changes reality, even reaching back in time. The universe behaves differently when we watch. John Wheeler's delayed choice experiment takes the double-slit mystery further. We decide whether to measure a photon's path only after it's passed the slits, yet our choice seems to determine its past behavior. If we look, it acts like a particle, if not, a wave. In quantum reality, the boundary between past and future is a foggy, uncertain frontier. After exploring the universe, let's return to the space between your ears. Physics describes time, but your brain creates the time you experience. Your brain is a master illusionist, editing, delaying, and stitching reality into a seamless story. What you feel as now actually happened a fraction of a second ago. Your experience of time is a brilliant ongoing creation. In moments of intense fear or danger, like a car crash, time can feel like it slows down. This is called tachypsychia, a psychological effect where adrenaline floods the brain, making us hyper-aware and recording memories in vivid detail. The richer the memory, the longer those seconds feel. Our experience of time is shaped by emotion and memory, not just the ticking of a clock. We've seen time stretch and bend, but can it ever truly stop? At a black hole's edge, time appears to freeze. And in the far future, the universe may reach a state of perfect stillness, no change, no movement, time itself fading away. Is this the ultimate fate of everything? After our journey to the edge of black holes and the corridors of our minds, we must ask, is time an illusion? Physics shows time is flexible, shaped by gravity and speed, yet our brains make it feel real and personal. Time is a grand tapestry, woven from physics, entropy, and our own experience, so cherish every moment of the incredible tapestry you are a part of.